So here I'm recording two at once, so this one's going to look weirder. Okay, there we go. Once we get that video started, it should be fine. Okay, so this is the algebra method. So you can use whichever method works for you. I like to say it's math. There are no rules. The only rule is you have to give a logical and convincing argument to back up what you're doing. Okay, so here we want to use some kind of algebraic technique to get the answer to this question. And again, there's two versions of the exam, so this may not be exactly the same as your version. But if you need to use algebra to translate this, it's still good to use a little bit of the intuition side. You should visually determine whether there's any flips in the graph to sanity check this. So you should notice that there's a flip in this direction, but there's no flip in this direction. So there should be this A is going to be negative, but the B is not. So just keep that in mind because sign errors are really annoying. You don't want to fall into those traps. Okay, so I'm going to pick 2 points, and I could pick 2 points like this for part of the problem, but I need 2 points that are not in the same line, that are neither horizontal nor vertical in the same line if I want to do the whole thing. So I'm actually just going to pick 2 different points. This is different from the answer key because I just want to show you have a variety of options. Here in this problem you have 3 points up above and 3 points down below that make sense to pick. So I'm just going to pick one above and one below. So I'm going to pick this point and this point. This is 3, -2, and this will work as long as I don't pick 2 points in the same line, in the same horizontal or vertical line. So over here is 7, 3, so I'm going to pick that point. And so what are the analogous points here? It's the second last peak, so it's 20, -6 over here, and the first peak is, well, we have to think about that, but it's something, 4. So the same logic I explained on the other video, that since I told you there's a 12 over here, oh, well, that makes it easy. Since I told you there's a point there, you know that one. But because I gave you a guide point, you have a good idea of the spacing. So for example, you know that this is 3 and this is 2. And that just helps you visually go through this process. Okay, so what are we going to do? We're going to base all of our logic on this formula, but we're going to split it into 2 parts. Okay? I'm going to, oh, I can't pause. Oh, well. I want to change the paper. Okay, so I want to pick these points, and what are they? I have a hard time remembering what I just picked. So I'm just going to put these on this page so I can work with them. So let me just get these here. So this point I have here is my first point and my second point, and then this is my first point and my second point. So this, I have to figure out how to go like that. So these are my F's, and these are my G's. And I'm going to call the X's on the F X, but I'm going to call the G independent variable T, even though it's really just another X. It doesn't matter what it is, but I'm going to give it a different name so that I can keep my work straight. So then I'm going back to this formula. G is equal to A F of Bx plus C plus D. And I want to figure out what all those letters are. And so I split it into 2 tasks. I split it into the task T is equal to Bx plus C, and I split it into G equals AF plus D. And so I can think of this as a table of values rather than a set of points. If it's easier, you can think of it as a set of points. So you have X, F, T, G. The X is 3, that goes with -2, and X is 7, goes with 3. T is 12, goes with 4, but these points are connected. This point goes to this point. So just keep that in mind. They're in a certain order. The order matters. And then this point goes to that point. Okay, so in this half of the problem, we're saying what t goes with what x. So this 12 is a t equals bx, so 3b plus c. And over here, we have the problem t, which is 20, is equal to 7b plus c. And I can set them both equal to c, or use whatever technique you're used to using to solve for. You just have 2 points and you're trying to find a line. This standard problem that you already know. So if we set these both equal to c and then set them equal to each other, so this is c for both equations, and then we can ignore the c, and then let's just solve for this. You get 4b equals 8, b equals 2, and so if b equals 2, you know 12 is equal to 3. I'm just going back to here. 3 times 2 plus c, so c is equal to 6. And so we have, did I do that right? I hope I did. See, if b is 2, yeah, c must be 6. So we have bx plus c. That's t. And then we use the f and the g columns to figure out g is equal to a f plus d. Don't worry about whether it's f of t or f of 2x plus 6, because it's the same f values. Those same f values are getting matched to these g values. So g is 4 a f plus d, and then so we got this from matching those guys up. And then the other one is negative 6 equals 3a plus b, and again we set them both equal to d. So 4 plus 2a is equal to d is equal to negative 6 minus 3a, and then ignore the d. And then we're going to put, let's say, 5a on this side, negative 10 on that side. A is equal to negative 2. If a is negative 2, then d must be 0. So we have all the information we need to figure this out. So what did we say? We said a was negative 2, and this expression is 2x plus 6, and d goes away. So what we have is negative 2f of 2x plus 6. The other version of the exam ended up with a question that was, oh, I completely messed this up, because, sorry, I did what you guys do, but what I didn't do that you guys do is I check my work. And when I check my work, I realized I screwed up a step. Okay, so right here, I forgot to invert this. So I have to solve for this. T minus 6 equals 2x. T minus 6 over 2. Sorry. This one is, let me go back to this expression. This expression was correct, but 2x plus 6 was wrong. T equals b x plus 6, but I have to solve because I got my variables messed up. So it's t minus 6 over 2. Or if you prefer, t over 2 minus 3, your choice. Doesn't matter which one you use. Okay, so the reason why I figured that out is I went back to this plot and I said, was this right? So here's what happens. If you go up here and you try to put the wrong one in, you'll get the wrong answer. So now that we have the right formula, we'll get the right answer. So we say, okay, when we put the x in, what happens? You get 6 minus 3 is 3. Go back to f. 3, get negative 2, times negative 2 gives you 4. That's right. When we had it backwards, okay, when we had the wrong formula, this thing simply wouldn't work. If we had said, well, I got rid of it. Okay, 2x plus 6, if we tried that, then we would put 2x and get 24 plus 6 is 30, and then we would try to go back to this graph, and there's no 30. So I'd say, hold on a second, I did it backwards. And so I would catch my error. So always, always, always check your work. Recheck always. If you don't recheck, you're going to be walking away from tons of points when most of your work is correct. I think I'll just go ahead and leave the video like that, because you need to see that you need to check your work. And hopefully that will help you